Hello everybody, welcome to this channel. This is Vivek along with my team presenting this video. This is part 3 of SQL tutorials. So in this video, we will be discussing about the various keys in SQL language with some practical examples. SQL keys plays a vital role in data retrievals and data updates. SQL keys are used to fetch the required data from your table for your data analysis and report building. So we need to have a thorough understanding of these keys and how to use them to retrieve the required data. Here is a list of SQL keys available today. We are not going to use or will not be using most of the keys in day-to-day life. There are very few keys we use predominantly for data retrievals and data updates. Let's go over one by one. The very first one which we most of us use frequently and popular is the primary key. So primary key is a unique identifier where it helps us to identify a row in a relational database. Some of the properties or attributes this key should have is the column which is defined as a primary key should have contain unique values, and it should not contain any null values. This could be a single column or multiple column in a table, which can be used to uniquely identify the rows. So every table should contain a primary key. This is one of the requirement for the when creating the table. The next one is the prime foreign key. A foreign key is again a primary key in some another table. So we use foreign key to join tables. Again, the foreign key cannot contain a duplicate values in the table where it is defined as foreign key, but the other table where it is a primary key, it again follows the rules of the primary key, following the uniqueness, are not null, those things. So primary key, foreign key is primarily used for joining the tables to establish the relationship among the tables. The next one is a unique key. So unique key is contains the unique values, like the primary key. The only difference between the primary key and the unique key is unique key does allow the null values, but primary key does not allow the null values. So this makes the difference between a unique key and a primary key, and many scenarios we use unique keys to retrieve the data. The next is alternate key. We don't explicitly define this as an alternate key in any table definitions, but this has the attributes of the primary keys. It does not have any null values, and it does has a unique values. The only thing is we can define only one key in, as a primary for a table. So because of that property, the other keys, even though they have the properties or attributes of primary key, we call them as alternate keys, and we use only for our um, data retrievals. We don't specify them as a primary alternate keys explicitly. The next one is a composite key. We normally call them as a concatenated key. This key is formed by concatenating one or more columns to form a key. So individually, when we see each column, they may not be having the key attributes, but when it is concatenated with other columns, they form a unique key to identify a unique row in a table. Next one is we call as a candidate key. Candidate key has can have multiple candidate key. Many times these candidate key work as a primary key in many scenarios. Again, we cannot have multiple primary keys. In that case, we use this candidate keys, but still they have the attributes of the primary keys. They don't allow duplicates or null values. Super keys. This super key is no longer used, but all the keys like primary keys, unique key, or alternate keys, these keys are subset of this super keys. The super key can be one or more columns that can uniquely identify a row in these tables. And we no longer use super keys nowadays. So let's see a SQL statement to create this keys. Here I'm trying to create two tables. One is a student table, another is a course table. The student table here, the student roll number is a primary key, and then ID is an integer which is not null, and going to work as a unique candidate key because it has the properties of both not null as well as uniqueness. We can define multiple constraints when we create a column. Likewise, the student enroll number is not null and unique. We can call this as alternate key or a candidate key because it has the attributes of the primary key. Again, then we have the other two columns: student first name, last name. Those are normal columns, which is not used as a keys. The last column is the course ID, which is defined as a prime foreign key. Um, and has this is will be a primary key in the course table. So that is the property of the foreign key. Any key which is defined as a foreign key in one table is going to be a primary key in another table. So here course id is a primary key in the course table. So we can join this student table and course table using the from foreign key. Again, this course ID in the student table can have duplicates or even nulls. It doesn't affect, it doesn't have any constraint in the student table. Whereas the same course ID in the course table has a constraint and it should follow the attributes of the primary key. It cannot have a duplicate values and it cannot have a null values. So here is an example of a student table with a few data inserted. So here, as we saw in the previous slide, student roll number is the primary key. Here, student enroll number and student ID, we know we can use it as a unique key and also alternate key as well as a candidate key. Candidate key and alternate key follows the attributes of primary key. These all three together forms together or comes we can call as a subset of super keys. Here course id is a foreign key in the student table, and the same course id is a primary key in the course table. So we use the course id to join both SQL student table and the course table. For if we need any course name for a student who took a particular course ID and we want more information like what is the course name, those things. In that case, we join the student table with the course table to fetch the course names. That's what whenever we need additional informations we want to look for in another table. In that case, we use these foreign keys to join. So with this, we are coming to end of this video. Please let us know if you have any questions in the comment sections. We would be happy to answer your questions. We'll see you in the next video. Thank you for watching.